And we're back. Welcome back, everybody. Today we'll be discovering the concept of structs. Remember last time when I told you that we would finally learn how to return multiple types together? Well, this is kind of the concept of a struct. But in effect, a struct is ideally just the way for you to create a whole new type that represents whatever data you want to represent. For example, let's say we want to represent a student. A student has a couple of things. We might have a variable for their first initial, car, first initial, and let's say my first initial is a V. A student will also have a second last initial, so another car for last initial. A student can also have an age, so an unsigned int for their age. My age is 25. And lastly, a student may have how many classes they're taking in school. Unsigned int num classes. And that would be, let's say, 3. So while a student has all of these things, what if I wanted to make a new student? I would effectively have to copy all of these over again and make them true for another student as well, except because I already have the variables first initial and last initial, I would have to rename these variables to be first initial, let's say 2, and last initial 2, and age 2, and num classes 2, to kind of represent that these are whole new variables that are holding some other value. And in this case, these variables may be slightly different. You might have A and M for their last initial, and age might be, let's say, 20, and this student might be taking 13 classes. But when we read this is actually really, really clutterful to read. So this is actually exactly where a struct can come into play. If we know for sure that every student is going to have a first initial, a last initial, an age, and the number of classes they're taking, then we could go ahead and effectively use what's called a struct to make a new type called student. And this is a user-defined type. So you as the programmer are now allowed to make types. Think of it like the computer has defined what int is, but the computer has no idea what a student is. However, for your use case, we are going to declare that a student is the following. A student is a type that has an initial, a first and last initial, an age, and num classes. How might we do that? Well, the first thing we're going to do is we're going to use the keyword struct to define our type. Then we're going to say what the name of the type is, and in this case, the name of the type is student. And then we're going to put 2 curly braces and a semicolon at the very end. Now, inside this struct, we're going to go ahead and make all the members of our struct. So in our case, the members of the struct are just the variables. The members of our struct are just the variables that we've already defined. So now that we have all these variables, we can simply go ahead and put a semicolon at the end to follow the syntax of a struct. And there you have it. We've just invented a whole new type of called student. And the student type has the following members. It has the member of first initial, which is of type character. It has the member of called last initial, which is of type character. It has the member age of type unsigned int, and the member num classes of unsigned int. And now that we have a new type, we can effectively do what we're allowed to do with every other type. With every other type, we can assign to a type, we can make a variable of that type, we can pass that type into a function, we can get that type back from a function. So think back to int. Think back to all the things you can go do. With an int, you are allowed to say int x is equal to 0, for example. You could then go ahead and update x to equal 10. Similarly, you can make a function, void foo, which takes in a parameter of type int into itself. which does something. You can also make another function, int bar, which returns a variable of type int. So similarly, with our new type, which is a student, we can kind of do all of these things. But now, instead of int, we can replace all of these with student. Now, how exactly these are going to work, I'm going to get back to you in a little bit. But I'm going to let you know right now that this one, this line, and this line do not compile. We have to go and update them because on the right side of the equal sign for both of these, what we have is we have a integer 0, and on the left side we have a variable named x of type student. It doesn't make sense to set a student which has a whole bunch of things including 2 characters and 2 integers to be of just the value 0. It's not really there yet. Similarly, this variable x, and on the right side is the number 10. We can't set the variable x, which is of type student, once again, to a value which is of type int, because our student type doesn't mean anything for student to be a value of 10. So before we dive deep and actually understand how we're going to use student a little bit more, I want you to understand the following things. A struct is basically a collection of types that are all put together to make a brand new type. In this case, to make a new type, here's what I did. I first used the keyword struct. Then I named my type, and I can name it anything I want. So in this case, I chose to name my type student. And then I made 2 curly braces for the scope of the struct, and I ended it with a semicolon. Then each of these inside the struct is considered a member of the struct. Every member of the struct has to have 2 things. It has to have the type and the name of the member. So in this case, this struct has the following members: first initial of type character, last initial of type character, age of type unsigned int, and num classes of type unsigned int. And for each of these members, we're going to put a semicolon at the end to indicate that that is the end of that definition for that member. So now that I have done this, I have officially finished making my type of student. Let's go ahead and jump over onto our code, and maybe we can do some live examples to see exactly how to use this code. And once we have some live examples, we're going to jump back here and do some memory tables to really make it sure it clicks whenever we use structs. Let's go right ahead. So, as always, let's make our type student, struct student. So now we're going to go ahead and define the members of the type. And the members are car first initial, car last initial, int unsigned int age, unsigned int num classes. And now, if I want to make a variable of student type, let's do this. So the first thing I'd want to do is declare the type of the variable I want to use. So in this case, the type of the variable is student, not the name, the type. And then I want to go ahead and name my variable. So I can call my variable Joe. So now I have a variable of name Joe and of type student. The value of this variable will come to in a little bit, and similarly with the size. But let's say I wanted Joe to have a first initial of J. I could go ahead and say Joe, and then to access the members of the struct, I can go put a period. And now you'll notice I have a choice of selecting any of the first initials. So let's start with first initial. And I'm going to put an equal sign because I want to assign a value to the first initial member of Joe. And now I'm going to say the first initial of Joe, the variable Joe, is J. And let's imagine that Joe had a last initial of S. I could similarly do the same thing. The value of the member last initial for the variable named Joe is S. Now what if I wanted to give Joe a middle initial? Let's try that. I could do Joe.middle initial equals K. And what you'll notice when I run this code is I'm getting an error on line 15, so right over here, and the error I'm getting is that Joe has no member called middle initial, no member named middle initial in student. So what this is telling me is that my variable type, Joe, which is of type student, has no member named middle initial. And if you look up here, that's exactly what I can notice. My variables have no member that is called middle initial. So I actually can't give Joe a middle initial over here because I haven't told my struct, my custom type student, that you also have to care about a middle initial. Instead, I'm going to go ahead and update Joe's age. I'll say Joe's age is equal to 20. And then Joe.num classes, Joe will be taking 3 classes. So now that I have my student type, now that I have my student variable Joe, and I've actually set a value for all of Joe's members to be of whatever they are supposed to be, the next thing to do is to make sure that this code runs. And indeed, this code runs. And the last thing I want to do is I want to print out Joe. So let's try doing that. All right, so now that I've printed out Joe, you might notice that I'm printing out Joe just like if Joe was of type int, that's exactly what I would type in. I would say std_cout Joe, which is whatever integer, std_del. But in this case, Joe is of type student. Let's see what happens. Well, the first thing to notice is that I'm going to get a bunch of errors. And specifically, it's going to tell me that the computer doesn't know how to print out my custom type student. Now, while std_cout has been programmed by C++, has been programmed to actually print out variables that are of type int, variables that are of type float, bool, and characters, std_cout has not been programmed to print out your custom type student. In fact, std_cout is only programmed to print out what are called primitive types, such as your cars, your unsigned ints, and your float. But because Joe is made up of these variables, we can actually still print out Joe. We just have to do some manual work. So for example, the following prints out Joe's first initial. Let's take a look. And there you have it, prints out the value of J. When I put the dot right after a variable, I'm saying I'm going to access one of your members. I'm getting the value of one of your members. So in this case, I'm getting the value of Joe.firstInitial. How are we going to do this? Joe.firstInitial is going to get whatever I set to be the value of Joe.firstInitial. So in this case, Joe.firstInitial was set to J. So I got the value of J. Now similarly, I can use the same technique to print out all of the variables, all of the members of Joe by doing the following. Run this code. And there you have it. I'm printing out J, S, 20, and 3. Now, you can think of variables on the left-hand side. You can think of members as just regular variables. For example, let's say I had another variable called int my age, which is equal to 25. With my age, I could say my age plus equals 1. Similarly, I can also say Joe.age plus equals 1. Because on the left side of this operator, on the left side of the plus equals, all I have is just another variable. But when I look at this variable, I have to look at all of it together. So when I look at all of it together on the left-hand side, I have Joe.age. So the first thing I want to notice is Joe is of type student, and student has a member called age. So I'm going to set the value of Joe.age to increase by 1. Now if I were to print this out, you might notice that I'm printing out 21 for Joe's age. Now, this could be very cumbersome. What if I also had a variable called Jane, and Jane.first_initial is equal to J. So Jane's last initial might be Y. Jane's age is 25. And the number of classes Jane is taking is 7. So what if I wanted to print out the variable Jane? Well, the first thing you'll notice is I could just copy and paste my code down here and just replace all of Joe with Jane. And now when I print this out, you should notice that I'm going to print out JS21 and 3 for Joe and JY25 and 7 for Jane. Now, this is slightly cumbersome. I would like it if I had a function that could print out my student type. So I can go ahead and make a function, void print student, and this function is going to take in a student as a parameter. So let's take a student type as a parameter. So the key part to reading this function is that this function is named print student. This function does not return anything, and this function takes in one parameter. That parameter is named val, and that parameter as of type student. So in order to print out a student, I can just copy and paste the code as before, and once again replace Joe with val. So now that I've done this, I can simply replace all of this code with print student for the variable Joe and print student for the variable Jane. And there, you can see that the code is doing exactly the same thing as before, but it is now using a function because we want to reduce some duplicate code. There's one catch though. Because this is of type struct, I might want to do some things that make this cleaner. So perhaps I want to do first initial, last initial, age, num classes, number. And when I print this out now, you'll notice that I'm actually printing out a whole bunch of stuff that's way more meaningful and easier to read than I was doing before. If you were to make a struct, I highly recommend writing your own print function for that struct. Now, a few quick caveats and a few quick gotchas before we dive a little bit deeper into how to walk through this code in a memory table. Just like how you're not able to use a function before telling the code what the function does above, for example, any function you describe cannot be described below the main function because your main function is going to be using that function. Similarly, any struct you want to use must be defined above where you are going to use it. The computer is going to read your code from top down. So if it ever sees something that it isn't familiar with, it's just going to tell you, I haven't seen this before. Are you trying to tell me something about this word? For example, if I describe student below the function print student, you might notice that I get an error. It's telling me on line 3, I have an unknown type of type student. That's because by the time computer read line 3, it did not see that I told it about a type of student. So in order for me to do that, I need to move student back above print student. And boom, there you have it. Now the code is working again. So let's go ahead and work this out on a memory table. I believe that's going to really help with the understanding of what's going on here.